Hi everyone. In the last session, we have seen how to write the factorial of a given number using functions. So in that, we have seen four different types of user-defined functions to find the factorial of a given number. In today's video, we are going to discuss a new concept that is called parameter passing techniques. So we will discuss what is the definition of parameter passing techniques. After that, we will discuss the methods of parameter passing techniques. Now let us have the discussion. What do you mean by the parameter passing techniques? See, in the yesterday's video, we discussed that how to find out the factorial of a given number. So we have used the function name in previous class, that is factorial. We have used this function factorial. Now, another important thing is in each and every program that we have seen so far, mainly consisting of one is main and another one is we are calling it as user defined functions. So like factorial. Meaning is here the communication is between one is the main and another one is user defined functions. User defined functions like factorial or any other. So how to provide the communication or the communication between the main and the user defined functions can be done by a set of techniques known as parameter passing techniques. In another sense, we call it as message passing. Message passing. But in C, mainly we prefer the technique called parameter passing techniques. In one word, I can say that the parameter passing technique is the way of providing the communication between the main and the user defined functions. Right? Now, we have called, I think in the last class program, we have called the factorial function from the main. So sometimes we have called the factorial function without passing any arguments. Sometimes we have passed the arguments to the function, right? The calling of the function can be done either by passing arguments or by passing addresses that we are going to see, right? Now, the parameter passing techniques broadly divided into two types. The first one is the call by value. First one is the call by value, and second one is the call by reference. So, what is call by value? See, the process of calling a function, the process of calling a function by passing, to say value as a parameter, value as a parameter. That's all. The process of calling a function by passing the value as a parameter. In the last session, we also discussed about what is meant by the actual parameters and formal parameters. So, in the method of communication or in user-defined functions, there are two types of parameters I said. The first one is actual parameters, and second one is formal parameters. Formal parameters. See, actual parameters are nothing but the parameters that are passed to the function. The parameters that are passed to the function are called actual parameters. Passed to the function. Right? Now, what do you mean by the formal parameters? These are the parameters which are received by the function. The parameters which are received by the function. Or in another sense, I can say that the parameters which are used at the time of function calling are called actual parameters. The parameters which are used in the function definition are called the formal parameters. Right? We will see with example. After call by value, the next parameter passing technique is call by reference. What do you mean by the call by reference? The process of calling a function, the process of calling a function by passing addresses, as parameters. Instead of saying addresses, we can also say references. References. That is the main difference between the call by value and call by reference. Still now, we didn't call a function by passing addresses or the references. In the factorial program, just we have passed only the values as parameters. So whatever the factorial programs or whatever the functions that we have seen so far comes under only the call by value. In today's session, we will see both call by value and call by reference programs with an example. So before moving on to the programs, first, I will give the clarity about what is meant by the call by reference in detail. To go into the details of call by reference, first we should know the concept of pointers, right? So let us have a brief discussion on the pointers. After that, we will move on to the practical programs to implement call by value and call by reference. Still now, in summary, I can say that the communication between the functions is done through the technique called parameter passing techniques. At the time of calling a function, the function may be called by passing ordinary values, or the functions can be called by passing addresses or references. If you call a function by passing addresses, what happened in the called function and what are the changes that we are going to see in the called function and in the calling function that we are going to see, whether we are going to get any reflections or any effect in the called function or calling function. And when you use the same concept of call by value, are there are any changes in the in the called function or calling function that we are going to see in detail, right? So before moving on to the programs, so let us have the discussion on pointers. This is very, very important. Why we are discussing about the pointers? Why? Because to know the concept of call by reference or call by addresses. See here, I'm going to give one example. You see here integer a comma b. How many variables we are declaring? Two variables, right? Now assume that a value is 10 and b value is 20. Okay. As we discussed in earlier classes, an integer may take either 2 bytes or 4 bytes. It depends upon the machine architecture, the compiler, or we can say it is the compiler dependent. So in our Visual Studio Code, an integer has taken 4 bytes of memory, right? So mainly the minimum number of bytes are 2 bytes, right? So here I'm going to draw the memory locations, right? And the name of the variable, first variable is a, and the name of the second variable is b. A and b. What is the data type of these two variables? Integer. Now integer takes how many bytes? 2 bytes. Okay, in some systems it may take 4 bytes. That is different, right? So 2 bytes. This is also a 2 bytes. Now the value here is, what is the value here? 10. What is the value here? 20. Here I'm writing 20. I said that whenever we use the variables, those variables are automatically stored in the memory and they are going to occupy some amount of memory, and each memory location is given an address. Who is going to give the address? The compiler is going to give the addresses. What are the values of the addresses? Unknown. Generally the addresses are denoted using hexadecimal number notation, but for simplicity I'm writing some integers like 100 and 200. So generally they are declared as hexadecimal numbers, right? Now assume that for understanding purpose, I'm assuming the address of A, the address of A is 100, the address of B is 200. Carefully listen, right? The memory location, each memory location is associated with three important things. Very, very important. The first one is the name of the memory location, name, and second one is the value of the memory location, and third one we are talking about address. Now if you take first one, the name of the variable is a, the value is 10, the address is here is 100. Now for the second variable, the name of the variable is b and its value is 20 and its address is 200. 100 and 200 is not fixed values, they can change. Why? Because those are the default values, are the values which are given by the system. They may be changed. Why? Because wherever the memory is available, that amount of memory is allocated for the variables a, b, and the addresses may be changed. Now the thing is, now here I am writing another type of variables like integer star ptr1 comma star ptr2. Right. So here also I am declaring the two variables. One is ptr1 and another one is ptr2. What do you mean by this? See, here also I am taking two memory locations, right? The name of the first memory location is ptr1 and second memory location is ptr2. Now, see, the main difference between the AB and ptr1, ptr and ptr2 is star. What do you mean by star? See, here AB are the ordinary integer variables. Please remember, AB are the ordinary integer variables. Now, here ptr1 and ptr2 are also the variables, but these are not ordinary, they are special. The speciality is denoted by star. Now, what is star? Generally, we use star to declare the pointer type variables, or we call it as pointer variables. Now, here the important term comes in. What is mean by a pointer variable? See, a pointer variable is a variable which consists of the address of another variable. Now, see, the value of ptr1 here is 100. This is the reference to a, carefully observe the line here, ptr1 consisting of 100. 100 is not an ordinary value. It is the value that represents the address of a. Now, similarly, ptr2, I am writing it as 200. It is also not an ordinary value. It represents the address of b. Here, the address of b, I said, is here 200. Right? Now, like an ordinary variables a and b, the variables ptr1, ptr2 are also having their own addresses, which are given by the system. And assume that the address of the variable ptr1 is 300 and the address of ptr2 is 400. Assume that, okay? This is the, now see here, I said the value of ptr1 is the address of a. Now, to store the values, the addresses of ab, what you do here is, here you have to write ptr1. ptr1 is the variable. In the declaration only you have to say star, right? So in another statements, don't write star. So ptr1 is going to contain the address of a. How to represent address of a? Ampersand. And next ptr2 is equals to ampersand of b. That means ptr1 consists of address of a how much? 100, and ptr2 consists of address of b how much? 200. Now here you have to say that the ptr1 and ptr2 are nothing but the references to a and b. Whenever we write ptr1 and ptr2 at the time of function calling, meaning is you are passing addresses. You are passing addresses. That is very, very important. Means if you say ptr1, ptr2, that is same as ampersand a comma ampersand b. The process of calling a function by passing ampersand a comma ampersand b indicates that we are calling a function by passing addresses. This is a simple scenario about the pointers. Right now, another important thing is how to access the value of a. If you take a value, so for example, if you write a, what is the a value here? 10. If you take b, what is the b value here? 20. Now, just now I said that ptr1 is the pointer to a. Next, ptr2 is the pointer to b. Now, when ptr1 is the pointer to a or ptr2 is the pointer to b, you can also access the values of a by a and b indirectly through pointers ptr1 and ptr2. How it could be done? Directly a value 10 and b value 20 you can get. The same value 10 and 20 means the values of a and b indirectly can be referenced by using ptr1 and ptr2. How? If you say only ptr1, what you are going to get? 100. If you get only ptr2, you are going to get 200. But how to get the values at addresses 100 and 200? So other than in the declaration part, if you write star of ptr1, it indicates star of 100, and star of ptr2 equals to star of 200. That means star of, here the star meaning is different, and the declaration part the star meaning is different. So here it indicates that star of 100 means the value at 100, how much? 10. The value at 100, how much? 10. Now star of ptr2 means value at 200, how much? 20. By saying star of ptr1, we can access a value 10. By saying star of ptr2, we can access the value of b 20. So this is a way of accessing the values of a by and b indirectly, or by using dereferencing operator, that is called star. There are two meanings for the star. When you use star in the declaration, means that you are going to name a variable as a pointer variable. Whenever you use star other than the declaration, it indicates that value at address. So we will see in detail with an example program. So let us go to the example programs using Visual Studio Code, which mainly explains the concept of call by value and call by reference. Now let us see the program to implement call by value with an example program. Let us go to the Visual Studio Code and go to new file, right? Here I'm going to use the program called swap. Swap means to interchange, swap.c. Swap.c, or you use another program, another name, swap call by value dot c. Okay, now I'm writing the program. Just you write in comments program to implement call by value. Call by value. All right. This simple program. You write hash include stdio dot h. Right. Next you say integer main opening brace. Now here I'm taking some variables integer a comma b. Right. You say printf enter any two numbers slash n, right? Now you say scanf %d double quotes close comma ampersand a comma ampersand b, right? Now you say one thing, printf the values before swapping %d and you write, you give some space or you write slash t, that is your choice, right? And you write slash n. After that comma you say a comma b, right? Now you write you call the function here swap. The name of the function I'm going to take swap, and we are passing a b values. Okay, this is, I will explain each and everything, but here I'm writing void swap using the function declaration, right? So in the function declaration, now we are passing two variables of type integer. We are saying int, right? We know this is function prototype, right? Now this is function calling. See here, function prototype must be after the opening brace. Okay, so if you want to declare the function, it must be only after the opening brace of the main. You can declare the variables first, or you can declare the function first. That's your choice, but it must be at the first place. The calling of the function must be anywhere, right? That is very, very important thing you should know. So this is function calling. This is function calling, right? Now I will explain each and everything at the time of execution, right? Now here you do one thing, you copy the statements here, Control C, and here you write Control V. Okay, now final statement for the main is we call it as return 0, right? Every program we are writing return 0, right? After this, or you can write here. Now, after this, we are going to define the function. What's the name of the function? Void swap. Okay. Now here I'm saying integer a comma integer b. Okay. Here don't put semicolon, right? Here don't put semicolon. If you put semicolon, the control is stopped here. Opening brace. Now here you say you take a variable called integer, some temporary variable. I'm taking temp equals to a and a equals to b and b equals to temp. Now printf the values of a and b in swap function. Here are percentage d slash t percentage d, okay, percentage d slash n, and you can write here comma a comma b and you say integer. Okay, now you write closing brace, right? The values of here I'm writing here the values are the values before swapping, right? Here I'm writing like this, the values before swapping. Here you can say in main, right? Here also in main I'm writing here, right? Now if you do one thing, I will clearly explain this program. Here we are using the concept of call by value. You see here the execution starts from the main, sorry, actually the compilers scans the program from hash include stdio.h, but the execution starts from the main, right? After that, okay, this is a declaration of variables and this is a declaration of the function swap. So I said that at the time of declaring a function, the name of the variables is optional and the return type of swap is void, and it is going to take 2 arguments, right? This is function prototype. And now, so we are going to print a message that enter any 2 numbers, right? We are reading the value of a and b. Assume that a value 10 and b value 20, like we have seen one example. So now the values before swapping means before calling the function swap in main percentage d, how much? 10, and slash t means it gives 3 spaces, and again percentage d means it prints 10 and 20. Now we are calling which function swap, and what are the values you are passing? A value 10 and b value 20. See, we are calling the swap function, or the main is calling the swap function by passing a 10 b 20 as parameters to whom this function swap. This is called call by value. We are simply passing the values as parameters. Now see, in this highlighted statement, these a and b are called formal parameters, whereas in the function calling which are in the main, in the swap, the parameters a and b are called actual parameters. This is very, very important. So that's why I said that the values which are passed to the function are called actual parameters. The values which are, or you say the parameters which are ready to receive, the parameters which are used to receive the values which are defined in the swap are called formal parameters. Okay, now from here, see here, from here we have jumped to this spot. Okay, now what about these AB and these AB? These ABs are not same. These ABs are going to store in separate memory area, and these ABs are parameters are stored in separate area. Though the name is same, but these ABs belongs to main and these ABs belongs to swap. That you keep in mind. 2 copies are there, 2 A's and 2 B's, right? Now, Now we are taking a temporary variable in the swap function. Temp equals to a means the value of a here is temp equals to a means 10. A equals to b means a value is 20 and b equals temp in 10. So just a value is changed to b and b value is changed to a value is changed to 20 and b value is changed to 20. Now here within this block we are printing this. You see, we are printing this statement. Now here in this what happened? Just we are printing the values of a and b in swap. In swap, what are the values of a, b? They are interchanged, right? So here you are going to get a value as 20 and b value as 10. Up to this clear? Now, after completing this printf statement, now we are going to enter the closing brace. The closing brace here means the swap function is terminated and we are returning back to whom? We are returning back to main and we are going to execute these statements now. We have jumped from here to this function and we have returned back to this printf statement here, right? Now here the values before swapping in main, here we are getting a and b. See here, whenever you use the variables a, b within the block of the main, these a, b's belongs to the main, not belongs to swap. So we have changed the values of a and b which are used in the swap, but we didn't change the values of a and b which are in the main. Okay, the AB of main is different from the AB of swap. The AB of swap are interchanged, but the AB values of main are not interchanged. They keep unchanged. So here, what are the values we are going to get here by using this printf statement? We are going to get the statement as the answer you are going to get the values of AB before. See here, it is not before swapping. Sorry. So you have to say after. After swapping means after calling the swap function. So again, it is going to print 10 and 20 only. So before swapping, we have entered values are 10, 20. They have printed 10, 20. After calling swap function, we have entered into the swap and we have printed the values of A, B in swap. We got 20, 10 and we have returned back to the main and we are saying that the values after swapping in main A and B. Here the values of A, B again 10, 20 only. The values of A, B are not changed. So what I want to say is, in this program, we are going to use the concept of call by value. Whenever you call a function by passing the values as parameters, then whatever the changes that are done inside the called function, what is the called function here? Swap. We have done some changes. What are the changes? We have made A to B and B to A. Okay. And whenever you print those values in the swap, okay, the values are interchanged that they have printed as 2010. But whenever you come back to the main, those changes will not reflect the AB values of the main. So that's why we got only A value as 10 again, B value is 20, the values after swapping here, right? This is the main concept here. Now let us execute the program, whether we are going to get the same kind of output or not. Okay, some errors are there. Unexpected identifier, okay. In which line? 22. Okay, we check the error, go to 22. So here unnecessarily we are writing this closing brace extra, all right. Okay, Control S, now you run it. Also getting some error. Okay, variable is undeclared. So here temp, what is the error you identified? Here I have declared temp, but here I have not printed P, temp, right? Okay, so is there any mistake you once you check it? Now I'm going to run this again. Okay, so you see here, it is asking enter any two numbers. So I said A value I want to give 10 and B value I am giving 20. I'm giving A value 10 and B value 20. A, B are the properties of main, right? Now, we are printing the values of A, B before calling swap and after calling swap. You see here, the values before swapping in main, you got 10, 20. The values of A and B in swap means we are printing AB values in swap. In swap, you got 2010, you see here. In the function or in the called function, we got 2010 means changes are reflected only in the swap. Okay, the values after swapping in the main not reflected, right? Here again we are getting 1020. First we got 1020. After swapping also we are getting 1020. Means the changes will not reflected the calling function main, but temporary changes only done in the swap function. That's why we got 2010. So this is the main what to say, the changes that we are going to see when you call a function by passing the values as parameters. Okay, now we will see the call by reference program by doing some modifications in here in the same program by using the concept of pointers. Just now we discussed the pointers. So what we are going to do, so small changes. Now you do one thing, same program I am going to write. You go to this function declaration here. Instead of passing the values of A and B, just you pass the address of A, ampersand A, and you pass the address of B, ampersand B. Small changes, just we are passing addresses, not values. Okay. We have passed the addresses now. See, from this swap, we are passing addresses, right? Addresses are coming to the swap function. To receive the addresses, what we need? To store the addresses, what we need? Pointers. How to declare the pointer variable? You put star. So here I'm putting star. Integer star A, integer star B. What does it mean? Star A means A is a pointer variable which consists of the address of A. B is a pointer variable which consists of the address of B. Now here you say same logic, but you use temp equals to star A and you say star A equals to star B, right? Star B and star B equals to temp. Now, very important thing is here A, B are not ordinary variables, they are the pointers. Means this A, B, the star A, star B are indirectly pointing to the A, B of main. Okay. Now, whenever, see here, whenever you do some modification, whenever you interchange the addresses, then automatically the values are also interchanged. So, what is the output we are going to get here is, so whatever the changes that are done in the swap, so here what are the values we are going to print here? AB values. AB values here we are going to get as 2010 in the swap, and after completing the swap function, we are again return back to the main function. Here we are going to print the values after swapping. Here A, B values became changed, means we are going to get 2010. So the main thing I want to discuss is in call by reference or in call by addresses, whenever you do changes in the called function, those changes compulsory will reflect the values of the main. Okay. So in detail with a what you say with a diagram, I will explain how they can be changed, how they are going to change. That we will see in the next class if you are not able to understand now. I think it is understood. Okay. Now we will see the full explanation of pointers in the next class. The only thing you have to remember that whatever the changes that are done in the called function will also reflect the variables of the main function here. But this is not the case in the call by value. With this, I'm going to close the session. Thank you for watching. We will see more details in the next class.